Okay, let's go ahead and finish up section 3.7 with this example about population. So it says this is 2 years since 1992, and so it's not what it was initially in 1992, that's what it was in 1994. The population was 20,900. Ooh, population in thousands. Whoa, 20,900 thousands of people. So this might be in a country, state. Anyway, so wait a minute. If this is in thousands, then that would be like 20 million. 20 million. Nonetheless, country perhaps. So, and then what, 3 years later? So from here to here, I noticed that that is between 1994 and 1997. 3 years later, it went down. By how much? What is that? 525? Is that true? I better subtract to find out. 525. So over the span of 3 years, it went down 525. That is, so just to know the pattern or feel the pattern, right? That is, so the constant change, if we are to assume it's a linear relationship, well, it went down 525 over the span of 3 years. So each year it went down 175,000 people per year. That's a big decrease. Okay, let's see. So from here to here, how much did that go down? 375, take away, that's 350. So two sets of 175, it went down here. So here, so that must have been over the course of 2 years. Oh, so this actually corresponds with this. Tricky, tricky. Okay, and then 4 years after that, well, 4 sets of this decline. Let's see how much that is. 700. So in these 4 years, it started at 20,000, 25,000 and went down 700,000. So let's find out how much that is. Whoops. $19,325,000 of people. And then, how much from here to here, I wonder. So, well, that is a decline of 1,575. How many of these does it take? So how many constant changes do I have to do in order to get 1,575? Well, that's a division problem because it's asking how many sets of these are there in that. 9. 9 of these makes 1,575. So just to show my arithmetic to the side here. So that means 9 years difference here. Okay. And it says fill in the table and write an equation. Okay, fine. Well, we found our constant change, but we don't know the initial value. But we do know it's going down since 1992, so it's more, and it's 2 years, so 2 sets of this more than what we had in 1994. So, we need to take $20,900 and add 2 sets of 175, and that will give us 21,250. Okay, so the initial value, the initial population in 1992 was 21,250. And I really went like this. I was trying to undo this decrease. Okay, so write an equation. Got it. Here is the initial, and here is the constant change. All right, so it looks like the population in thousands is the initial 21,250,000 minus it's constantly going down by 175,000 for each year. I'm going to call that T for time. Population in thousands, T in time. In years since 1992. What is the slope of this line? Say what it means in the context of this situation. Well, the slope is the constant change, and that is negative 175. And that means the population has been decreasing by 100, and this is in thousands, remember, so 175,000 each year since 1992. It's a migration. What is the y-intercept of this line, and what does it mean? Well, the y-intercept, remember, is the initial. So b equals the initial is equal to 21,250. Say what it means. The population was initially, and this is in thousands, so 21,250,000. Because if it's this 1,000 times, that's 21,250,000 in 1992. Does it make sense to use negative y value or x values here? Okay, so remember, x values are the independent variable or the explanatory variable, and here that is the time since 1992. So this is actually t values here. Does it make sense to have a negative t value, a negative year since 1992? And my answer is actually yes. Here, negative t values represent years before 1992. Now, I'm not sure if this linear equation would fit for the years before 1992 because we're not given that data, but still, this is what it would represent. Use your equation to predict the population of the city. No. I don't know. Are there cities with 21 million people? Anyway, I guess it's a city. In 1989. Oh, so that would be a negative because that's before 1992. How many years? 3 years? So here t equals -3. Okay, so we go back to our linear equation and we're going to put in -3. Or you could backtrack if you want to. So the population is 21,250,000 minus 175 times -3 times. So previously, before the decline. Okay, so let's Add that on. And we get 21,775 thousands of people. Okay, so the population in 1998, or I'm sorry, 1989, sorry, about 21,775,000. Oopsie, thousand. Okay, in the city. So a quick summary about what this section taught you, or hopefully taught you, is that we can still make linear equations even if we weren't supplied the initial value or the constant change. But we have to find those regardless in order to find the equation. So even if we're not getting them, we still have to compute them somehow from what we're given in order to write the equation of a line. And because look, our equation depends on knowing the initial and the constant change. Describe the slope, the intercepts, and the solutions and what they mean. So here, we described, here's the y-intercept, here's the slope, and then in the blood alcohol content one, we also found the x-intercept and what it meant. Yes? All right. Till the next thing we learn.